Fluorescence-guided surgery uses light to help the surgeon identify structures and features. Surgeons are trained to trust their senses, so why do they need a special tool to see fluorescence? Light is an electromagnetic wave, and the human eye is only sensitive to a small window called visible light. Visible light includes all the colors of the rainbow, from violet to red. Special cameras and filters can be used to look for very specific colors and even light outside the visible range. It's a lot like how your car radio can only tune to one station at a time. Filters are thin pieces of glass that can be used to select certain wavelengths or very specific colors to pass through to the camera. Surgical guidance systems use cameras with specific filters to produce two images, one that mimics what the human eye can see, and another which is very sensitive to the wavelength or color of fluorescent light. Contrast agents convert absorbed light from one wavelength to another. The filtered camera captures the intensity of the fluorescence emissions. The fluorescence intensity is used to provide a real-time intraoperative view of the surgical field where the surgical team can toggle between visualization options. The fluorescence is collected as a black and white or grayscale image, and many system manufacturers display this information using specific color maps. Even when the original fluorescence image is the same, color maps may alter the perceived visualization. If the camera moves closer to the surgical field, the fluorescence intensity will increase, or moving further away, fluorescence will decrease. Certain obstructions, like adipose tissue, can obscure fluorescence. Another consideration, depending on the contrast agent and system design, are how the room lights or other light sources may interfere with the fluorescence detection. If the ambient light contains the same wavelength as the emitted fluorescence, this may result in interference, where the sensitive camera detects both signals. Following the radio analogy, this is similar to hearing two stations at the same time. Ultimately, fluorescence imaging enhances the surgeon's abilities by improving imaging contrast, but there are limitations that should be considered. System developers are constantly working to improve the sensitivity and specificity of their surgical guidance systems, and available technologies are continuously evolving.